Hello everyone, and welcome to lesson 1 of the Guitar Gaze learning course. My name is Eric Wright, creator of Guitar Gaze and author of a numerical and visuospatial method for learning guitar. This is the second video on my channel, Guitar Gaze, and the first of several guitar lessons designed to make guitar easy. My first video was a demo of the Guitar Gaze platform, which is used throughout this course as our tool for visualizing the fretboard, and this course is designed to deepen your understanding and accelerate your guitar learning by an order of magnitude by taking advantage of the natural shortcut built into the world's greatest instrument, in my highly biased opinion. In this first lesson, we're going to introduce a foundational understanding of notes on the fretboard and something called isomorphic tuning. And first, we'll go over a few things to make sure we're on the same wavelength. So let's get into it. Just briefly about my background, I didn't start practicing guitar until the end of college. I had a lot of lost years to try to make up for, so I started making these visual tools to better understand the true nature of the guitar and the arrangement of notes on the fretboard, what string intervals were, why standard tuning, why other forms of tuning, and this led me to develop a simplified color and number-based approach to music. You know, I call us simple-minded mere mortals, the guitarists who want to be like all of the amazing guitarists out there, but they just seem so unreachable. Us mere mortals, we need all the help we can get, and there's immense value in having multiple ways to think about a concept, especially music. So by using colors and numbers, other tools, and of course sound itself, we can add dimensions to our understanding of music. So whether you're at the beginning of your guitar journey or you've got years of experience, it's my hope that this learning course thoroughly illustrates what I consider to be a beautifully simple approach to understanding the guitar that can also add a new dimension to your playing. And I want to make it clear that what follows throughout this learning course is an unorthodox way of learning music, although it is grounded in music theory as well, something called interval pitch class notation, which we will get into in this and the following lesson. So this learning course and the Guitar Gaze platform unveil a numerical and visuospatial system for learning the guitar, as I mentioned. And this is designed to help you navigate the world of the fretboard and overcome the initial feelings of complexity and all the hurdles. You know, guitar can seem like this monumental beast to approach, and it is a challenging instrument, but the truth is the guitar is a remarkably simple instrument that is needlessly made extremely complex and abstract through traditional alphabetical note assignments and by not thinking of the guitar in terms of interval structures. In the images on this slide, if you see the top yellow, red, and blue image, and then the one below that, which just looks like, you know, a grid of boxes, you see these natural repeating patterns, or you just see this geometric translation. So if you can recognize the repeating patterns in those images, I assure you, you are capable of mastering the guitar. What you see in these images is just a geometric translation tessellation. And that means it's a pattern that can be moved around, or a repeating shape that can be moved around, and the shape will be maintained. This is the guitar in a nutshell. Furthermore, rather than using traditional note assignments, if we instead use numbers, we can see these symmetries that are built into the repeating patterns across the fretboard. And that's the third image here on the right. You see all of these numbers have an opposite of their value that is reflected across this central point. And we will get into that in lesson 2. We won't get all the way there in lesson 1. But the point is, you add colors, you add numbers, the guitar starts to make a lot more sense than if you're just using traditional note assignments. So this course will help you have an intuitive understanding of these, frankly, ingenious symmetries that are built into an isomorphic instrument like the guitar. And hopefully with enough practice, you'll be able to visualize these geometries in your mind and, you know, even play with your eyes closed and navigate through them in your mind as you improvise to your heart's content. That would be the end goal that I am also going for, and I am making good headway on getting there. Another quick note, as I said, the information and visual tools presented throughout these lessons are available on guitargaze.com. This is where I've built an interactive fretboard viewer with custom scale, chord, color, tuning, fret sizing, and even string count configurations. For example, if you're a bass player and you want to do 4 or 5 strings on the viewer instead of 6, or if you have a 7-string guitar and you want to do 7, you can add or take away strings. And I go over that in the first video, which is the demo of the platform. But the Guitargaze tool is also a listening tool and a tab builder, and there's a book on there and more. And just to show you real quick, in the Guitargaze full version, I've got it set to A major right now in isomorphic tuning, and you can just press listen, and now it's listening to every note I play. So I'll start with A, and I'll just go up this scale. So that can help you understand some of the concepts from this lesson and help you practice. It just puts a visual aid in front of you that can guide you and expedite the learning process. And that is my goal here, is to expedite the learning process. So this guitar learning method that I've touched on rests on a small set of ideas from music theory. None of them are difficult to understand, but we need to define them precisely to make everything that follows easier. Number 1, a half step. The smallest interval on the guitar, that's equal to 1 fret. So I'm going up by half steps there. A whole step is equivalent to 2 frets. That's a whole step. An octave is 12 half steps, and then the note repeats. So that's the 12th fret. Those are the same notes in different octaves. Every note repeats itself after 12 frets, and the entire guitar beginning at the 12th fret repeats itself. Octave equivalence is the same note in different octaves. So an example of that, if I'm starting on A, the next string open is also A. That's 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 octave equivalence. Same note in different locations and different octaves of the fretboard. Pitch class is the family of all notes that share a name across every octave. So every C is one pitch class. There are exactly 12 pitch classes. Every A is one pitch class. Or if you're thinking of things numerically relative to a root note, then you have what is called an interval. So the interval is the distance between 2 notes measured in half steps. So if you start with the open E string and you go up 5 half steps, 1, 2, 3, 4, 5, that gets you to A, which is the next string. So the interval between E and A is 5 half steps, or 5 frets. And the root note, if I picked E as the root note, then that could be the foundational pitch for if you're forming chords or scales, or you're improvising, or you've got whatever sound it is that you're trying to produce or go for is based on the root note, is relative to the root note, and harmonies and everything fall around and are designed around that root note, and then it changes whenever the key changes to a different root note. And in this learning system, which we will get into in the next lesson, the root note will be thought of as home base, or your central location. So that will be represented with the number 0, and then everything around the root note is expressed as its pitch class or interval class relative to the root note. A few more definitions. So as I just mentioned, the interval class is the family of all notes that share the same interval from the root note across every octave. So for example, if you've got E, A would be the 1, 2, 3, 4, 5, the +5 interval class relative to E. And that interval that I've been describing, the 5 half steps, which is the difference from string to string, that is referred to as a perfect fourth. A perfect fourth is equivalent to 5 frets or 5 half steps. Transposition is that those geometric figures we looked at just a moment ago. So you can move the same pattern to a different root note in a different location on the guitar, and because intervals stay constant, and for the most part the intervals from string to string stay constant, the pattern or the shape is preserved, and you can shift that around. Isomorphic tuning is a slight difference in tuning. So standard tuning on the guitar is E, A, D, G, B, E, and if you just change the interval between the G and the B string, so that these top two strings, instead of being B and E, are instead C and F, what that does is it creates a uniformity across all the strings so that they all have the same interval between them, and that creates what is called an isomorphic note layout, or all fourths tuning, or I will sometimes refer to it as CF tuning. So some quick notes on the fretboard. Here is standard tuning on the guitar. As I mentioned, the entire guitar repeats itself beginning at the 12th fret because of octave equivalence. And in standard tuning on the guitar, the intervals between all the strings are equal to 5 frets, except for the interval between the G and the B strings, which is equivalent to 4 frets or half steps. So you can see that on the image on the top here. You've got the A string is equivalent to the 5th fret on the E string. The D string is equivalent to the 5th fret on the A string, and so on. The E string is equivalent to the 5th fret on the string below it, the B string. However, the B string is equivalent to the 4th fret on the G string. That discontinuity makes the guitar not isomorphic. And that makes things more confusing, but for now, we'll just continue to talk about standard tuning on the guitar. So, keeping all this in mind, if we, instead of having just note assignments, if we also designate a color, which you can see on the image on the bottom, if we designate various shades of blue or orange to the natural notes, which are A, B, C, D, E, F, G in the C major scale, and then all the accidentals, which are the sharps or flats, aren't highlighted, we have this color layout, and you can see much more clearly what the patterns are on the fretboard. You can see much more clearly what the C major scale looks like. And it's probably a lot easier for you to make sense of what's going on just simply with these colors being added. Now let's address this discontinuity on the guitar. So as I mentioned, there's that one interval between the G and the B string that is equivalent to 4 frets or half steps. So if we just make a slight adjustment where we take the guitar and we, instead of having these top two strings being tuned to B and E, we tune them to C and F, then the interval between all of the strings on the guitar is equivalent to 5 frets. So that restores the repeating pattern on the guitar that is otherwise disrupted by standard tuning. With this adjustment, we have complete uniformity across the guitar, horizontally and in the vertical, and this is called isomorphism, or an isomorphic tuning. So with the interval being equivalent between all of the strings, we are more easily able to see the patterns that do repeat themselves across the guitar. So just take a moment to look at the animation here, showing the difference in the C major scale when you go from standard tuning to isomorphic tuning to standard to isomorphic to standard. And when it shifts over into isomorphic right there, you'll see everything kind of snaps into place and you've almost got this staircase pattern. That is the natural repeating pattern of the guitar, which we'll show in more detail later on. So why, if this makes it clearer and easier to see the natural repeating patterns on the guitar, why do people do standard tuning? Well, the reasoning behind the discontinuity in standard tuning is largely for convenience of finger placement when playing common bar chords. However, in standard tuning, there are only 4 unique positions that allow you to bar 4 or more strings across the 7 modes, including the major scale. But in CF, or all fourths, or isomorphic tuning, whatever you want to call it, there are actually 6 unique locations across the fretboard that you can bar 4 or more chords. So there are still plenty of opportunities for unique chord formations in isomorphic tuning. And furthermore, standard tuning comes with the massive inconvenience of creating the discontinuity between the G and the B string. adding unnecessary confusion to scale memorization and pattern recognition, effectively requiring you to learn 12 unique shapes instead of just one. So if you take a shortcut and you just adjust the tuning and think of the guitar isomorphically, it makes it a lot easier to learn the foundations for guitar, and then you can also apply that to standard tuning. So as we described earlier, we've got what is called a translation in geometry. That's the term used to describe a function that moves an object a certain distance. So the object can't be altered in any way. The shape has to be preserved. That is the rule in geometry. And this image here depicts in clearer detail with a broader viewing window the underlying translation of notes on the guitar fretboard. So my primary objective here is to show you what lies outside of the window of the guitar. And when I say outside of the window of the guitar, you can imagine what is to the right of and below the orange line here is your fretboard on the guitar in CF isomorphic tuning. And if you were to imagine that there were a bunch more strings on your guitar going into higher and higher and higher pitches, and you continued to color code the notes on those strings, this is what a guitar with that many strings would look like. So this is an important note because you can see that in addition to notes naturally repeating in the horizontal going along a string, so you have C, C sharp, D, D sharp, E, you also have a 12-note repeating pattern in the vertical within each fret. So B, E, A, D, G, C, F, A sharp, D sharp, G sharp, C sharp, F sharp, and then so on. That repeats. In the vertical, there is a repeating stack or column of 12 notes, just as there is a repeating pattern of 12 notes as you move up an individual string. I want you to drill that into your head now. So in CF tuning, each fret on the guitar essentially contains a unique 6-note window or segment of the same 12-note column of notes. That 12-note column of notes is simply shifted up or down vertically within each fret. That would be one way to conceptualize the guitar. So this repeating column of 12 notes is important for several reasons. For one, it makes understanding scales way easier and the similarities between scales way more approachable. This shows the major scales and the similarities between them. And when you're looking at a vertical column of 12 repeating notes, which are on the isomorphic guitar layout, you also notice that the various modes of major scales are simply the 7 adjacent notes taken from the repeating vertical column of notes in a different scale. So I guess in other words, the various modes of a major scale are made of the exact same notes as the other major scales in a different key. So just to clarify, if we start with F major, for example, F major is made of this segment or this stack of 7 notes within the larger column of 12 notes, and F is positioned second from the top in that stack of 7 notes. Now we go to C. It's the same thing except it's shifted down one, because in isomorphic tuning on the guitar, C is always one string below F. So you just take this same shape, the same structure for F major, and you just move it down one in your vertical column of notes. And C is also positioned second from the top. G moved down one, G is positioned second from the top, and so on and so on. All of the major scales are the same, just a different segment of the repeating pattern of 12 notes. And that's not readily apparent when you look at this figure on the right here that shows the list of the notes that are in each scale. I look at that and, what is obvious on the left is in no way visible or readily apparent on the right. So that's the benefit of having these visual tools and thinking isomorphically on a guitar. And here I just wanted to show you a little animation of what all the major scales look like on the fretboard in CF tuning. This is an animation from the Guitar Gaze platform. It just scrolls through the major scale on all 12 keys from C to C sharp to D and so on. So you can see that repeating pattern just sliding to the right, but you can also see that the vertical column of notes maintains the same note order. Similarly, chords are the same from key to key. Here we see the 7-note column for each major scale, which we just looked at on the last slide. And there are 3 notes in each of these major scales that comprise the major chord. They're colored in red. So the location of the notes of the major chord within its respective major scale remain in the same vertical position from scale to scale. So you'll notice the second from the top, third from the top, and second from the bottom note in all of these scales is what the major chord is comprised of. And again, the vertical order of notes from that 12-note tower is maintained. And here again, I just wanted to show you an animation of what all the major chords look like on the fretboard in CF tuning. This animation just scrolls through the major chord in all 12 keys, showing all of the potential finger placements that would be within the major chord. Something that we'll get to in future lessons, you can take any chord and you can overlay it with a scale, and you can see the degree to which it falls within a scale. And if it falls fully within a scale, that's called a diatonic chord. If it's partly within a scale, it's fairly agreeable but could be used in a transition or to add color to a chord progression. So having this ability to view chords and scales and combine them together, and also have it show you what you're playing while you play, is very useful, and will help overcome some of those hurdles of confusion about differences from scale to scale. There's a lot more to music than the major scale and major chords. We will revisit these scales and chords later. For now, just let this serve as sort of a scales and chords appetizer. And up next in lesson 2, we're going to introduce the other change on top of the isomorphic CF tuning change we made in this lesson. And that change is going to be representing notes with numbers instead of letters. So lesson 2 will be the numerical introduction, where we express the root note as 0 and all notes as either positive or negative based on their interval relative to the root note. And this will allow us to see even more repeating patterns and symmetries that are built into the guitar, which you can see in the images here. This, which I mentioned earlier, you have a natural repeating pattern on the guitar. Any location that you have a root note in one corner and a root note in another corner, that box contains within it a ton of symmetries. The entire box is symmetrical about itself, which I will describe in more detail in the coming lessons. This diagram maybe looks a little complex right now, but I assure you after lesson 2, it will make a lot of sense. So that's the end of lesson 1. Thanks so much for listening. I hope this got you excited about a new approach to guitar, and I hope to see you in the next lesson. Cheers.